Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects, titled Efficient Load Optimization with Gray-Wolf Optimization Algorithm. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the demonstration for the research area that we have designed for the demand side management in the electrical domain specifically. So this is basically management and scheduling using optimization algorithm. Before moving to the video, let's talk about that what we will cover into this video. This research area is related to the electrical domain and the real world application where it can be helpful in the power grids and power plants. So in this video, we will cover that what application areas it is useful, where it can be implemented in the real scenario. Along with that, whatever the code we have designed, how to execute it, what are the software and library requirements for it, and what kind of data it is asking. Along with that, what are the current systems those are working over it, and what are the problems identified into it, and the overview of the work done in our proposed methodology will be discussed in this video. Finally, whatever the experimental outcomes and findings are there, we will give an overview to that also. So let's talk about the application areas where it can be implemented in the realistic one. So as it is related to manage the power requirements and generation, so it is very much helpful in the power and the energy sector, where the growth can be and the management of the resources can be managed for the power grids to make the system as a smart grid, so that as per the demand and the requirements it can schedule the things like for how much how much demand is there, and how to manage that those resources can be managed in order to save the natural resources. For the demand side management, that in order to control the environmental issues, their demand management systems can be effective enough. So this is very much helpful in that areas. Power systems, where electric power generation can be controlled in order to avoid the resource overutilization. So in that areas it is very much useful. So the industrial level or even the real world government projects, those are working on scheduling that how much power is to generate and when to generate. Even the scheduling can be done under this particular domain. So let's move to the next section, that what exactly the code and how to execute it. So we will provide you the folder. So this is the whole folder having the different information with them, with the real-time data set. The data set that we have collected is from the power grid for the a particular area. So we can't give you the details that for which area the data is there, because it was a confidential one. We once you are gonna discuss about it, we can give you the references for the publications. Those are already referring such kind of data. So what exactly this data is? This data is basically the details of the actual demand at different time intervals, and the demand felt on that particular areas is there. This is in megawatts. Along with that, whatever the initial plan they have decided that for which particular area, for which particular section, how much and which grid is to be on and not. So this is AP, PAT, RDS. This is for the commercial, industrial. These are the domains. So these are the different time duration during the whole day at a difference of 15 minutes, where in reality after the 15 minutes the data is to be the scheduling is to be managed. So this data set is the requirement of the system. So this the whole code is generated in the MATLAB. So in order to run the code you must have the MATLAB with you. So the MATLAB version that I'm using here is 2019a. Make sure the MATLAB whatever you are using must be 2018 or above, and must be a full version, not a trial version. So to run this code you just need to go to the folder here, and you just need to copy the path of the folder where the code is placed, and then paste it here and press enter. When you will press enter you can see the whole code is here. So these are the main files. So we have represented the work for the three different months, like as of May, this is for June, oh sorry, April, May, and this is for June. So for three different scenarios, what we are considering the how much maximum power can be extracted out for them, how much share of the one unit can be given to the another one, as pat is one of the domain um, which can get 10% of the AP. So obviously whatever the actual stats we got from the industry and the power grids, we have mentioned that, and on that behalf the 10% of pat is given of AP is given to pat, and when the remaining part is given to obviously the AV. Similarly for MJG, these are the grid information. So 70% of it is to be given to the MGAG and rest to the RDS. And last three are the information related to the urban areas, as well as this is for the industrial areas. So after giving this information, so this is for the UHBVN and this is for DHBVN. So these are the two different units under which it is working as per the real time information about it. So we have split it as per the realistic word and made the information set. Then those excels has been implemented where the felt and demand met has been separated, and then as per the information that we have arranged at the upper part, is it is checking that how much of that demand value is having the share in them. So this is the demand for urban one, and this is for the domestic one. So on that we have shown that for the 96 sections, because in every 15 minutes they are managing it. So obviously in a day it is a 24, and in an hour they are 4. So 24 by 4 it is in 96. So we have generated a slot of 96, that is having after 15 minutes generation. So what is the demand felt is put to the variable demand felt and then to the met. So accordingly as per the share given in the above sections, it is generating the initial information and getting that how much demand is there as per their working hour scenarios. So there are certain restrictions with the running hours scenarios, that for how much time the pat is to be run, for how much the industry share must be there. So all the information is required to be there. So we have run for the different three scenarios, and then in order to get that when the AP part is to be scheduled, when the industrial is to be scheduled, so that they can get the demand. For example, if it is a 4196 megawatt, then during the days minimum 8 hours electricity is required. So it is to be scheduled that when it is to be operated. So when I'm running this code, you can see it is the initial phase where the initial plan whatever was designed by the manual processes by the experts is given as an input, and on that we have the fitness is calculated by using the functionality you can see here, as per covering every areas as per the requirements. So later on, taking it as a reference, we have applied the GW optimization algorithm. So GW optimization algorithm is applied to get the better outcomes. So here the GW started and it gives us the results which must be greater than the initial fitness which was generated by the manual process. So when I'm running this, to run this code we just need to click over here, and you can get the variations that how the demand is to be met, and in every iteration the fitness is varying. So we have run it for number of iterations, because it needs some time to schedule the things for the different sectors like urban share, industrial share, MGAG, PAT, RDS, and AP. Electrical person are more information, have the more information related to these terms in a power grid where the power is to be generated and demand is to be fulfilled. So it is running for number of iteration. The iteration that we have given into it is basically for individual one it is 100, so that's why it is taking some time to execute the all the iterations. So we are waiting for this to get finished. So for individual section, until the system is not getting the better results with respect to the initial fitness, it will start execute, it will keep executing and can get the outcomes to achieve that requirement. So the challenge was that in order to run this code, you just need to click on the run button and it will start working. So currently there are certain people, those are working into domain. So this is the paper that we were following. They have done for the multi-objective dynamic scheduling. So they were just doing the scheduling that when it is to be run, but we are working on the real-time scenarios data which we have collected from the industry of the power grid, which is government officials data. So on that we have applied the optimization algorithm. So many of the people are giving different strategies to fulfill it, like they are seeing the patterns or something and predicting the future or something. But scheduling thing is not only the prediction, it is as per the demand requirements. So we have applied the optimization algorithm in order to achieve the best results. So this was the reference where they were using the PSO algorithm, but PSO is a very old optimization algorithm, and certain different and new strategies has been proposed. So inspired from the literature study, we have applied gray wolf optimization. So you can see after so many runs here, you can see I'm running the code again. I just closed it. You can see when I'm running this code, it will start processing it. And for different months, this is for May, because the stats we do have along with us for the 3 months, that is May, June, and July. This is for May, this is for June, and this is for July. So as per that, the requirements and the demands have been changed, but the share is obviously similar for every section. So we have applied the graphical user GWO, gray wolf optimization algorithm to get the better outcomes. So GWO optimization algorithm, so it is a gray wolf optimization algorithm which was given in 2014, and even the further modifications are still possible into it. But in this particular domain, whatever we are implementing with the real-time data, with covering the multi sectors, because the paper that we are following, that is for only static data and is only for one particular unit. So in our scenario, it is for the multiple sections, like for industrial, urban, and many other things. So once the code is executed, let's see what results we do get. So this is the slots, that in every slot for 96 slots or at the interval of 15 minutes individual, what was the demand felt, what demand was met, how much share is for AP, RDS, PAT, MJJG, urban, and industrial. So this gives us the information of every slot, that what was actual the demand and how much share is to be given to which sector. So you can see it is not limited to only a single one, it can be applied to as much sectors we do have to cover as per the requirements and the share of there. So in the fitness evaluation, it took a total of the iteration. Let's see how much iteration it took. It took a total of 498 iteration to get the better outcomes in comparison to the basic plan, initial plan given by the manual processes. So it is giving us the schedule, that in the morning, in the first 15 seconds, which sector is to be on and which sector is to be not, to which the demand is to be supplied. So it is giving the slots which is to be operated in the 96 sections of the day at the interval of 15 minutes individual. Along with that, it is given that this was the tradition and the optimal schedule, where the old, the means initial plan which was made by the professionals, and our scheme is given here and giving us the difference that how it is effective. So in the result scenarios, it is giving us that this was the load and the demand felt. This is the comparison of demand felt and demand met. So you can see the demand met is obviously covering many of the sectors in order to avoid the issue. So this is the fitness that we were achieving during the GW optimization algorithm. So the initial and the optimal fitness is having a differences of around 3 points. So you can see the initial plan that they have made was 3280.40 and our is 3277.54. So as many runs will be there, it will be obviously giving us the better results because the condition that we have applied is that. So this is the plan that when the switching is to be done for the AP sector, this is for PAT, this is for RDS, this is for MGJG, this is for this is the comparison that what is the initial plan they have given and what we have given in order to fulfill all the requirements and the conditions for these different sectors. So we have done the comparison for the every sector also. So this we have done for the different months with the real time data collected from the industry of electricity generation, so that we can defend it and can easily show it. So all the stats have been automated, and can be used in the real world. So this gives us the automation in the scheduling of the demand management. So further modifications are still possible because optimization algorithm is implemented to it. Further artificial intelligence or the recent variant of the other meta-heuristic approaches can be applied to it. Even for more modifications can be possible. So for more details you can contact us and can get the details. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPax, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPax. We look forward to collaborating with you on your research journey.